You should now have a dual color LED connected to the GPIO extension board through the breakout board. We have the black wire ground connected to physical pin number 20 ground, and we have the yellow wire, which is the R pin, connected to physical pin number 12, which is GPIO pin number 18. Let's take a look at our code that we're going to be using for our first project. First of all, anytime that I want to run new code, it's a good practice to go into the directory and see if there is new code that needs to be changed to the most recent version. So if I open up the terminal, I can navigate to my folder. And just as a reminder, you need to be in the ATTC folder that we've downloaded from the GitHub repository. Inside the folder I have the appropriate labs, and this will change over time as we begin to pull more from the repository. In order to get the most recent version of the code, I'm going to use the command git space pull. And we can see here that there is a change in the repository. One file has been changed. Yours might be different based on when you pulled from the repository. If it says all files are up to date, then you are up to date and you don't need to do the pull. So let's close the terminal, and we want to open up our Ninja IDE. The Ninja IDE, we want to close all the lab, the start page, and if you haven't already, we want to open the project. So select Open Project, and I'm going to navigate. Let me come back to where you probably are. So I'm here in Pi, and I want to go to Desktop, and then your project, and then into the 3260 folder. Now, because we're only working on Lab 2.0 right now, you could open just this project directory. I'm going to open all of them in ATTC 3260. So I select Open, and now I have my lab over on this side. I already had this running, so I'm going to hit a refresh project just to ensure that I've got the most recent version. The way that I've numbered these labs is to try to help to identify which one we're currently working on. So here we have Lab 2.0. 2.1 is the first lab where we actually program against the LED. The first set of code that we're going to be running is 2.1.0. So this indicates this is the first code, this is the second code, and the third code. Okay, so go ahead and open LED 2.1.0 LED on. This is a fairly straightforward code. We're hoping that this, I hope that this is not overwhelming, that we have the minimum amount of code to be able to turn on our LED. The first line that you'll notice in the code is talking about Python. This is a way for us to assign or to tell the processor that we want to run whatever version of Python we have assigned. In previous videos, we took and made Python 3 our default. So that's what it'll grab is Python 3. You could actually assign both Python 2.4 and 3 and then change which one you're going to run. But Python 3 is the one to learn, and moving forward, we're going to only use Python 3. The next statement is known as an import statement. So I have import space, and then what I am importing, I'm bringing in information from a library. The library that I want to bring in is RPI, which stands for Raspberry Pi GPIO. That library someone has already written that allows me to connect to the GPIO and program against it on the Raspberry Pi. So this is the name of the library, rpi.gpio. The as is very similar to an equal sign. I am assigning the library, giving it a shorter name, and I'm calling it GPIO. I could actually just call it G, but as we learned earlier in videos, it's best to put a variable that has meaning. GPIO for us has meaning. I have a space right here. You don't necessarily have to have a space. The program will just ignore this, but this makes it a little bit easier to break up my importing statements with my variables. I like to put the variables at the top, and then I can make modifications as needed. What's happening here, remember I've made this could be anything. Pin underscore R is what I've assigned it because that makes the most sense. We're working with pin R in our dual color LED. So I'm saying pin R, but keeping in mind that this could just be R, right? So this doesn't have any meaning except for us when we're programming. The computer doesn't care what this word is. So pin underscore R, I want to assign it a value of 12. Okay, all I'm doing is assigning it a number. We're going to see how that number is then going to be used in order to determine that the pin that we want to turn on is pin number 12. The benefit of using a variable like this is I can make changes. If I suddenly wanted to change this to pin number 14, the only place that I have to make the change is up here at the variable. So pin R is going to turn on by way of commands that I'm doing down here. This line is only assigning it the value of 12. Next, I'm using GPIO. Remember, GPIO is how I'm accessing the library. That library has a method known as setMode. So I type GPIO dot setMode. The setMode method allows me to tell the CPU how I want to use the GPIO numbering system. We learned earlier that there was a way for us to use the board or physical location of the pin, and we also learned that there was a way for us to use the chipset's pin locations. Because the physical location is a lot more intuitive, we are going to use board. So board tells the library that all the numbers that we're handing it or passing to it are going to be associated with the physical location. I've put a comment here, and we remember comments aren't executed, they're simply just for our benefit, that the number for GPIOs is by physical pin location. So this is only telling the CPU that, hey, we want to use the physical location rather than the BCM location. The next line, remember all of our pins, well, the majority of our pins are either inputs or outputs. They can be either one. We need to designate or tell the board that we want to use a certain pin as an output or an input. In our case, we want to turn on a LED, so we are using an output. So I have GPIO, which is this library. There's a method in that library called setup. Setup allows me to assign a pin to be either an input or an output. In this case, I'm assigning the value of pin R. Now this pin R is our variable up here. I could put 12 right here. It would do the exact same thing. The reason that I don't do 12 and I use a variable is if I was assigning a lot of these during the setup and I went back and said, oh, whoops, this is supposed to be 14. If I change this to 14 up here, there's no change that's made to here. This will be changed to 14. And so it's best to always pass it a variable and then you can make the change. So we're going to change that back to pin R. Now when I run setup, this pin R is a 14. And if I had multiple places, which I do, I have pin R right here and pin R right here, the number 14 is substituted in for that. So let's change this back to 12. The next parameter that I'm passing the setup method is an out. So GPIO, the library GPIO, I'm telling it that it is an output. So it will be sending out, it will not be receiving in the electrical signal. So I'm setting the physical pin 12. Now in the comments, remember 12 is only because I've assigned pin R to number 12 to the mode output. Alright, so all the code from here up, this is only setup. I'm just setting up the board to start working with it. Now I want to run the actual code that will turn on the LED. Here I have GPIO, which is the library GPIO, and a method known as output. I need to pass two things to the output method. I need to tell it which pin, and the pin that I'm telling it, once again, I could write 12 right here, but I'm giving it the variable name pin underscore R, and I'm telling it to go to high. GPIO.high means to go to the on position. GPIO.low goes to the off position. So here I have a comment to help us remember what that is. Set the R pin, so number 12, to high, and high is 3.3 volts for the Raspberry Pi at this GPIO. So I set it to high, and that should then turn on the LED. Alright, so this is the most basic program that we'll be running against the Raspberry Pi in order to turn on the LED. So if you've made any changes, make sure you get the code changed back to this version, and let's run this now in the terminal in order to see our Raspberry Pi turn on an LED. Alright, let's run our code. So open up a terminal, and in case you're not at the appropriate spot, I'm going to go back to the root. So I'm going to navigate to desktop, and then the name of your projects folder, and then remember we need to be in ATTC 3260. Running the ls command, we can see that there are two different labs. We're working on lab 2.0. And now I'm in Lab 2.0. I want to see which of these programs that I'm running. We're going to be running the 2.1.0 LED on. So if I want to run a Python script, I'm going to type in the word Python, and then I'm going to put a space. Now, there's a lot of characters in there. You might not even know how to put an underscore down. So just type the 2.1.0 and press the Tab key. Now I'm ready to execute this program. When I press enter, you should see something happen with your LED. Alright, we got our LED on. That's exciting, right? We used a computer program. A computer is outputting and turning on an LED. That's great. There's a couple problems here, though. Now that we have returned to the Pi at Raspberry Pi line, that means that the code has run and it is done. Most Python scripts will run and then we have to cancel and stop them. So the Python script is run and it's done. It's exited back out, and I'm back on the terminal and can do anything I want now. The problem that we have is the light is still on. So maybe let's try running the program again. So this second time that we run the program, we notice that there's a problem. And if we look real closely, we see that this channel is already in use. So the problem is we are turning the LED on, and then the program is ending, and then it never turns off. And so we're going to look at some ways that we can turn off the LED, right? If we're going to turn something on, we should probably have a method to be able to turn it off. So we'll look at the next set of code that we will use in order to make sure that we can turn on and off the LED.